The animal is moving normally, but the muscle is green, completely made out of muscle cells today, but that came from the bone marrow. You trigger a heart attack, the heart becomes filled with new heart cells, but they're green. Burn to the skin, in the kidney. This is in the lung. And this is a cell in the pancreas that is making insulin. We'll come back to that later. So a cell, a normal cell of the pancreas making insulin that comes from your bone marrow. So I just showed a few examples to just illustrate that we went from a traditional knowledge telling us stem cells can only become blood cells, and suddenly what is revealed is that stem cells can become cells actually of various tissues. When these first observations were made, and I'm not criticizing here scientists, but there's two ways to look at this. It would be a little bit like knowing that we have butterflies, that we have caterpillars, and having never seen that the butterflies come from the caterpillar. The first time that you observe a caterpillar transforming into a butterfly, it's a big discovery. Now you can draw two conclusions. You can be hyper-conservative and say, well, that was a weird caterpillar, and only that caterpillar became butterflies. Or you can be a little bit more daring and say, if that caterpillar became a butterfly, then butterflies come from caterpillar. Now you still need to demonstrate that that is true, but I'm more of the second type. You know, if I see one man fly, then we can fly. You know, it's not that that one was special. So if stem cells can become brain cells, liver cells, and heart cells, then why not pancreatic cells, and skin cells, and joint cells, and lung cells, and cells of other tissues? And if they can, then they have to. Meaning, if a stem cell can become a cell of the brain, it cannot just be a weird cell. It has to be that this is its natural function. So if it is its natural function, then that means they are the repair system of the body. So it was a big stretch at the beginning. So we published this article in a journal, Medical Hypotheses, in which we simply proposed stem cells constitute the natural repair system of the body. At the time, it was a very far-fetched idea, daring idea. In many medical conferences, when I was lecturing on this, I remember one where at one point there's a scientist that stood up and he said, "Son, I have to tell you something. Apparently nobody is telling you. You're just an idiot." So it's just to show that whenever you bring a novel understanding of things, there's a lot of, I wouldn't say resistance, it's novel. And at the time it was early in the process. So now let's fast forward 15 years, 18 years later, and here's what we can say of that process. Now there are literally hundreds of studies documenting various aspects of this phenomenon. This is now very, very well accepted in science. I won't say very well known, because it has not yet crossed the research lab to academia. So it's still not what is going to be taught in med school, but it is very, very well documented. So anytime there is an injury in a tissue, it can be, a lot of these studies were done with heart attack, with stroke, broken bones, but we can extrapolate and say anytime something is happening in the body that is not normal, then the affected tissue will release compounds that are today very well known in medicine. These compounds, when they reach the bone marrow, they trigger the release of stem cells from the bone marrow. So stem cells detach from the bone marrow, reach the blood circulation, and start to circulate. So within about 2-3 days after the injury, peaking at 5 days, there'll be an increase in the number of circulating stem cells. Now, we all have stem cells in circulation, just like we all have red blood cells, white blood cells, platelets. We all have a certain number of these cells. There's a healthy range. Same thing exists for stem cells. The healthy range has not been established yet, but the range will be anywhere between 0.05 stem cell per microliter to 5 stem cell per microliter. So you can see the range is about 100-fold. So there can be a big difference between individuals. And at the end of this presentation, what I want you to see is that the number of stem cells that we naturally have in circulation is a huge determinant to tell us how quick we can heal and how effective the body will be at maintaining its own health. But where we start here, the increase in the number of circulating stem cells will be about 3 to 10-fold above baseline level. When stem cells are released, they don't know where to go. They don't know what is a tissue that is in need of repair. So starting on the second day, the affected tissue will release another compound locally in the local area of the injury. So as stem cells circulate everywhere in the body, and they circulate in the fine capillaries of the affected tissue, that compound that is released locally, when it touches the membrane of stem cells, it triggers the migration of stem cells out of the blood into the tissue. And then the stem cells will then in the tissue continue to see where the injury is, where that molecule is being released. The stem cell will crawl to the site of the injury, and when it arrives at the site of the injury and gets in contact with cellular debris of that tissue, it will do like in the beaker, it will multiply and transform into cells of that tissue. It is your repair system. Anytime you've had an injury in the past, this is how your body repairs. So you've got the release of stem cells from the bone marrow, the circulation of stem cells, the migration, and then the proliferation and transformation of cells, stem cells into cells of the target tissue. Now, it's obvious that all these steps are essential. Stem cells need to circulate, they have to migrate in the tissue to become cells of that tissue, but in science, remember before, you cannot see this phenomenon until you have that green molecule. Likewise, you cannot discover bacteria if you don't have a microscope. You cannot discover stars if you don't have a telescope. If you don't have tools to trigger migration or block migration, you can't study migration. So the part of this whole process that has been studied the most is the release of stem cells from the bone marrow, because we have these molecules that are known and they're used in medicine. When you trigger the release of stem cells from the bone marrow, the consequence is that you have more stem cells in circulation. So what scientists have studied the most is the link between the number of stem cells in circulation and health. So let's look at what we find here. When we look at this, there are a number of conclusions. The first conclusion is that more stem cells in circulation means that more stem cells are available to participate to the process of tissue repair. Let's look at a study. So I'm going to pick a number of studies here. I don't want to be too technical, but I just feel that showing the data